Good afternoon. Welcome. I'm Ed Bogucz. I'm Executive Director of SyracuseCoE, New York State's Center of Excellence in Environmental and Energy Systems, and it is my pleasure and my thrill to welcome you to our 14th annual symposium. It seems like yesterday that we were doing our first annual symposium, so it's great to be back here at the Crown Plaza for our event today and tomorrow. As you've seen in the program, we'll start this afternoon with 3 keynote talks, and then we'll adjourn over to the Center of Excellence headquarters, where we have 57 student posters and opportunities to see the labs. I want to thank our sponsors for assisting us in providing for the event this year: NYSERDA, Carrier, Johnson Controls, C&S Companies, Tatum Engineers, and Quality Environmental Solutions and Technology, Quest. I also want to remind folks who wish to get continuing education units, CEUs, from either AIA or GECI to be sure and sign in and sign out at the back of the room. You know the procedure. And if you'd like to participate in a building tour at the headquarters in the program later, please grab a ticket at the desk on the way out. And now, without further ado, I'm pleased to introduce Shere Abbott, who's Vice President for Sustainability Initiatives and University Professor for Sustainability Science and Policy at Syracuse University. We'll share welcoming remarks. Shere?
Thanks, Ed. On behalf of Syracuse University and our new Chancellor, Ken Severide, who I guess isn't new, but he's not as new. He doesn't have the 14 years history that the COE Symposium has, but it's my pleasure to welcome you here today. One of the key strategic goals of this COE this year has been to re-engage with the academic community of the university, faculty and students, and into more of our programs. And together with the further engagement and deepened engagement with the community and industry, so it's a real pleasure to see so many faces, from young faces in particular, in the audience here. So more faculty and more students across our colleges and academic programs. So welcome. It's really great to see you, and as well as our partners from the 40 some odd institutions and firms who are also represented across the couple of this next day and a half. So both the breadth and the depth of the symposium program and the attendees hold the promise for the kinds of co-produced knowledge that we hope to generate. This is producing jointly from labs and markets the innovative ideas and services that will be both intellectually stimulating and economically invigorating. So I thank the members of the program committee. I don't think everybody is here for their dedicated work. Professor Jensen Zhang, who chaired the committee, Hugh Henderson, and Professor Bess Krietmeyer, who I see here as a co-chair, and Professor Rob Spetz and Josh Stack. I haven't seen Josh. I see Kevin over here, but I don't see Josh. As you know, the theme of this symposium, Advanced Building Systems Integrating Efficiency, Quality, and Resilience. Each of these elements is essential. Addressing them simultaneously takes both the range of disciplines and the wealth of practice represented in this room, working together on integrated systems and solutions to complex challenges in design, technology, processes, and services. This audience surely appreciates the urgency and importance of the theme. 2 recent climate assessments, the National Climate Assessment for the U.S. and the AR4 from the Intergovernmental Panel on Climate Change for the global scenario. Both of these assessments remind us, and unfortunately once again, that climate disruption is not a future issue, that we are likely not dealing with incremental change, but an existential threat. It's here, it's now, it's in our forests, our coasts, our cities, our backyards. My former boss at the White House, John Holden, used to say we have three options for dealing with climate change. The first is mitigation, measures that reduce the pace and the magnitude of the changes in climate that human activities cause. The second is adaptation, the measures that we take to reduce the harm that results from climate change that we do not avoid. And the third is suffering. The latter because we're already committed to a climate-changed world, a new climate world. The question is, what is the mix going forward? Well, the symposium themes in the sessions couldn't be more relevant to addressing this balance in efficiency, in quality, and in resilience. So one comment about resilience. When I was at the University of Texas at Austin, and we had a meeting between our climate change experts and the mayor of Austin, who at the time was Will Wynn. Mayor Wynn said, you know, you scientists are great at studying problems, what you call the vulnerability of natural systems and communities. Well, I can tell you that as a mayor, I'm not telling citizens I'm going to make them less vulnerable. I'm going to tell them that I'm all about making them and the city more resilient. So resilience is in the air. President Obama announced recently a national plan on resilience to prepare the U.S. for climate change impacts, in addition to a whole series of executive actions focused on reducing carbon pollution. In September, Governor Cuomo signed the Community Risk and Resiliency Act, which provides tools for the state and local governments to prepare an adaptation scenario, sort of a down payment on the future. 4 weeks ago, Mayor Bill de Blasio reaffirmed that New York City commitment alongside President Obama's national commitment for an 80% reduction below 2005 levels by 2050, or 17% below 2005 by 2020. This is not as easy as it sounds. So the need for this symposium is great. Innovations to improve built environments are going to be key to addressing these challenges. Innovation demands knowledge from science, know-how from technology and practice, rapid data and information sharing, and a whole lot of collaboration. So that's what this is all about. New York State has played a leading role in the development of cutting-edge research and the deployment and commercialization of technologies designed to improve energy efficiency, indoor environmental quality, and resiliency of built environments. And like many universities throughout the state and the county, Syracuse University is attempting to do its small part to reduce energy consumption and reduce its carbon footprint. And through the SyracuseCoE and a wide range of academic programs, we're providing opportunities for learning and discovery across the university structure. So we celebrate this year's 14th SyracuseCoE Symposium, bringing together this very rich mix of students, faculty, and practitioners. I challenge you over the next day to make the most of the next day and a half to co-produce knowledge with new people, but mostly to learn and discover among yourselves all the new things that we need to know about advanced building technologies. So may you enjoy a truly excellent symposium, and welcome to this different venue for the symposium, which is also quite nice. So thank you.
Now to introduce Jensen Zhang. I want to say a few words about Jensen, and then he's going to introduce our first speaker. The enterprise that now is known as the SyracuseCoE originated in two plans. One, a regional economic development plan for the central New York area that was developed in 1996, and a strategic plan within the College of Engineering and Computer Science at Syracuse University in 1996. As part of the strategic plan for the college, we started hiring faculty members and investing in facilities, and Jensen was the first faculty member that we hired. It was 1999, November 1st. So Jensen's completing his 15th year, and actually Jensen organized with National Grid our 0th symposium. So actually there's a proof of concept in 2000 at the Faculty Center. It had maybe 40 people, and specifically on indoor air. So I want to thank Jensen for his leadership at Syracuse. The Bees Lab at Link Hall that Jensen envisioned and built for building energy and environmental systems is known internationally as a innovative tool for understanding the interactions of outdoor and indoor environments. And we greatly appreciate that Jensen led our program committee this year. So without further ado, Jensen Zhang.
Thank you, Ed, for the very kind introduction. And I add my welcome to all of you, and thank you for coming to this wonderful symposium. It is my great pleasure and privilege to introduce our first speaker, a keynote speaker, Professor Bill Bahnfleth from the University, Penn State University. Bill served as the ASHRAE president in the 2013 and 2014, just last immediate past president. And he is the professor and director of the Center for Indoor Environment at Penn State. And he received his degrees, BS, MS, and PhD degrees from the University of Illinois at Urbana-Champaign, which I also received a degree from there. And he also received a music degree and pipe organ, so he certainly has many talents. He is also an educator. He teaches many classes in the undergraduate and also at graduate level, covering across many areas from equipment side to the system side and to indoor environmental quality. And he has published many papers. He's a scholar and researcher, and over 125 papers and 12 books and book chapters. So he's a very productive researcher as well as an educator. And he certainly is a leader. He participated in the leadership role in many technical committees at ASHRAE and also served as the ASHRAE president. He's also a personal friend to me, and I know he does everything with tremendous energy, intense energy. I'm always impressed with the energy he has. And just last year, he has traveled about 30 countries around the world, and as president of ASHRAE, he's trying to reach 50,000 ASHRAE members, and also constantly sharing his experience through the Facebook. So his energy levels is incredibly high, and today he's going to tell us how much energy, or whether we have put enough energy into indoor environmental quality. Let's welcome Bill.
Thank you, Jensen, and thank you for the introduction. It's an honor to be asked by a friend whose accomplishments I admire very much to lead off this meeting. And I think this is my third time up at Syracuse to speak, and it's always very enjoyable to be here. So before I begin the formal presentation here, I suppose I should say that I cut my teeth in the built environment industry as a consulting engineer, so I started out actually on the ground doing design and trying to give clients systems that they were happy with. And then I went to academia and learned how to be a researcher and to focus more on that. And the thing that I got out of being president of a large technical society was being forced more into the policy arena and dealing with issues of how do we get things done. And so this particular talk had its genesis as something that was meant to be an incitement to recognize a problem and to do something about it. I think that we have lots of great history of research in indoor environmental quality in buildings, and the question is, what are we going to do and when to get it into practice? So that is the origin of the title, and being aware of time, we'll just move on from there. Buildings are, as everyone knows, I would hope, the largest single end user of energy. In the US, it's about 40%. In many countries, it's about 40% of the total. roughly evenly distributed between residential and non-residential buildings. Actually, in the US, residential buildings consume more than half of that total. So it's a very important issue. And of course, so is the related issue of climate change that comes along with it. And so I simply want to stipulate to that no matter what I say here, I recognize that, or what you think I'm saying, I recognize that the energy issue and the global environment issue are very important. And I want to make an argument to bolster the importance of the indoor environmental quality issue as well. So where does the energy go in buildings? We use lots and lots of energy. What are the end uses when we break them down? Here is the DOE average building from their surveys in 2010, which means you'll never find a single building that is exactly like this because it includes all types. But when you add up the end uses and try to allocate them to things like indoor environmental control, you find that almost 60% of the energy is used to control the indoor environment in some ways, lighting or thermal or air quality. And if we look at the things that we would call heating, ventilating, and air conditioning, that is almost 50% of the total. So we're using a lot of energy, and we're using that energy in buildings predominantly to do what we would call indoor environmental control. So there's a direct linkage between those two things, energy use and control of the indoor environment. And the question is, what kind of indoor environment are we trying to create? If that's what's causing the energy use, then are we sure that we have the right goals for what the indoor environment should be? A point that I think is becoming more generally known now outside of indoor environment circles is that if you try to put a value on indoor environmental quality, it becomes readily apparent that the benefits of a good indoor environment are much more valuable than the energy that's used to create them. And they are, to some extent, distinct problems. But if you want to put everything in terms that everyone understands, which is how many dollars or RMB we're spending, indoor environmental quality is more expensive. 1 to 2 orders of magnitude difference in the cost of energy to run buildings and in the value of what goes on in there that people are involved in. We spend maybe $1 to $3 per square foot in the US for energy. $2 would be your rule of thumb. The annual costs or the value of what goes on in buildings, 1 to 2 orders of magnitude greater, $80 to $600 per square foot, just as a rough order of magnitude. It's been estimated in some studies that were done at Lawrence Berkeley National Lab that we could save on the order of $300 billion a year in avoidable problems caused by poor indoor environmental quality, by lighting and acoustics and air quality. And interestingly, if you look at the DOE's data on how much energy cost is associated with buildings in 2010, it was $431 billion. So what they're telling us, if you believe that, is that there are savings there or value that could be obtained that's equal to what we're spending on energy every year, and yet we don't do it. So the first version of what has become this talk was something I was asked to do at ASHRAE's IAQ conference in 2013 in Vancouver. That's a conference that has been put on every 3 years, most of the time since 1986. And so I went back and looked at some of the history of it and at what the themes were this year. And as you can see there, the title of the conference in '86 was Managing Indoor Air for Health and Energy Conservation. And in 2013, it was Environmental Health in Low Energy Buildings. So we've been going for about 30 years, and we're still trying to address the same issue, and you find some interesting things when you dig into that. Another interesting thing is that my father was the president of ASHRAE in 1986, and he created the Environmental Health Committee, which put on the first IAQ conference. So he had to make State of the Society remarks at the end of his term, and he pointed out two things there. I've excerpted from it. You can see two big problems that are on the horizon, new things we have to deal with. One is the problem of energy conservation, and the other is the problem of air quality. And the very interesting thing here, it says that not many people are talking about conservation, but it's really important. On the other hand, we're recognizing that indoor air quality could be the most important health concern for the remainder of the 20th century. And if you absorb those two statements and then think about what has happened in the ensuing 30 years, you wonder whether anyone paid any attention to this remark and why things turned out the way they have. 30 years ago, we had a very clear idea of where we wanted to go with indoor environmental quality. Here's an excerpt from the remarks that were made by the chair of the first conference, and I've underlined the important part that indoor environments should minimize any impact on health and free of impact on comfort, and control should minimize the use of energy. So here's that idea of integration that was there, fully formed, as fully as it's ever stated today. And again, this was in the 1980s, before many were paying much attention to this at all. To go one bit further with digging up the historical comments, here's another remark from my father's speech that says that here was the first important collaboration between those who are involved with the health of people and those who are involved with the design and operation of buildings. I would argue that partnership, although it got off on the right foot, has not advanced as far as it needs to in the time that has passed since then. So now let's look at what has happened since 1986 or thereabout. ASHRAE standard 90.1 has been ASHRAE standard since the 1970s for energy use in buildings, and the stringency of that standard, the minimum acceptable efficiency, has been pushed down and down and down. And probably the best way to look at that is in this figure. If we set a level of 100% for back in the 1970s when the first edition of the standard was published, and we look at the 2013 version that just came out, we're now down to roughly 50% of the energy use of that original minimum code acceptable building. I don't know if we could say that we have achieved similar improvements in any other sphere of performance related to buildings in that time. There's been immense pressure to do this. It's come from the industry itself, it's come from government, it's come from the public, and that's why it's happened. When you think about how changes like this happen, you really need to have everyone on board. You need to have those who are the experts, who are in communication with those who make policy, and the public needs to believe in it too. And that's how you get things like what's been happening around climate change and around energy efficiency in buildings. And I think that's great, and I want to see that happen with indoor environmental quality as well in the near future. So what have we done over the same period to make IEQ better? Have we really gotten this integration, and have we moved the ball forward from where we were in 1986 very far? Why do we have global movements to stop climate change and to reduce energy use, and nothing really comparable yet for indoor environment, even though World Health Organization will tell us that 8 million people a year are dying from the effects of fine particulate matter, 4.3 million indoors. So let's look at what we call acceptable indoor air quality today. And this is taken right out of ASHRAE's standard 62.1, which is referenced in many, many building codes in some form. So there are two important aspects to the definition. One is that acceptable indoor air has no known contaminants at harmful concentrations as determined by cognizant authorities. So if we don't know about them, we're not dealing with them. And if no one knows if they're harmful or not, we're not dealing with them. The real operative part of this definition is the last one. A substantial majority of the people exposed do not express dissatisfaction. So what we continue to opt for after decades of research into indoor air quality is a standard that says if people think the air quality is okay, then it's okay. And if all of them think it's okay, it's great. And of course, any one of us who has any background in chemistry could go pick up a reference and point to a number of things that are odorless and colorless and entirely lethal, either in the sense of acute toxicity or chronic effects. So from that point of view, this definition doesn't do anything. And it also doesn't really address the issue of, is the air quality optimizing my quality of life as a person? Is the indoor environmental quality contributing as much as it can to my health and to my productivity? Not just, do I not notice that the air smells bad? So here's the kind of approach that we've taken for as long as I've been active professionally to define ventilation for air quality. We expose test subjects to their own self-generated pollution, and we ventilate that at different rates, and then we poll them and find out what percentage of a group believes that the air quality is unacceptable, and then we set a criterion for the maximum unacceptability that we'll tolerate, whether it's 20% or 15%, and that is the basis of ventilation standards with a few fine points that are not worth going into in a talk of this nature. So the US standard, the European standard, all are based on perceived air quality, as it's called. So let's poke around at that a little bit and see whether that's really a good standard. If I go back to this slide for a moment, you'll notice there that Class B air, 20% dissatisfied, 80% satisfied, is about 7 liters per second per person, and 10 liters per second per person is what is corresponding to about 15%. That's Class A air. So now let's look at a few of the studies that have been published, and a lot of these were nice efforts by Bill Fisk and others at Lawrence Berkeley National Labs to pull together many studies and summarize them. Here's one that looks at relative prevalence of sick building syndrome symptoms as a function of per person ventilation rate. And on this particular chart, you see that the reference value of 1.0 is at ventilation rate of 10 liters per second per person. And you'll notice that as the median of these studies in the center of that region of uncertainty is decreasing all the way out to about 30 liters per second per person. So this quite clearly would say that 50% or 100% more ventilation air, at least based on these studies, would lead to reduced incidence of sick building syndrome symptoms. Whether this is exactly the right relationship or not is not the point. The fact is that study after study shows that kind of relationship, that the perceived air quality does not correspond to maximum performance. So acceptability is a low bar. Productivity has been studied in a number of different ways as well. Most of the studies have looked at repetitive lower level tasks, answering the phone, how many times can you do it per hour, how many errors does one make in certain kinds of tasks. And when you look at those sorts of studies, you see basically the same thing, that there is improvement above these levels of 7 to 10 liters per second per person, and it's fairly significant up to 2 to 3 times that amount of ventilation. So here we're seeing 3 to 4% improvement in productivity over that range, which is very significant in terms of profit margin. Suppose that this is someone just producing something that you get 3% more and you don't have any more employees or pay them anymore. That's a very significant number. And of course, we also have the concern that I alluded to earlier, that air quality is killing millions of people, which certainly affects their productivity as well. What we're seeing here is largely the impacts of fossil fuel combustion with poor control, and most of the deaths are concentrated in what we would call developing economies in China and in India and other parts of that region. And the indoor portion of this 7 or 8 million per year is largely due to indoor uncontrolled biomass combustion for cooking and heating. So it's definitely a developing economy issue, but to some extent it affects every country. And so we don't leave the rest of indoor environmental quality out here. I'm focusing on air quality because we have limited time. We have the same kinds of effects that I showed for air quality that are associated with the thermal environment. So just one small slice here is a plot from a study by Sepinen and Fisk that again summarizes multiple studies that shows that relative to some optimal temperature and humidity condition, if you're too warm or too cold, your performance decreases. And of course, I think everyone knows that subjectively from their own experience. We also notice that there is a strong connection between thermal environment and between perceived air quality. Studies have reported numbers like 12% increase in sick building syndrome symptoms per degree centigrade, increase in temperature above 22.5. So that's an important connection, and all of these things that make up indoor environmental quality, particularly thermal and air quality, and then lighting, and then acoustics, contribute to the overall impression and to whether we're productive and healthy. So with that rather small bit of technical background, there's a lot more that we can talk about: school studies and higher level thinking studies. What's my view of the status quo right now? The research community for indoor environmental quality is well developed, strong. There are many brilliant people doing good research there. It's underfunded to some extent. It's not coordinated as well as it should be with practice. I think that's the big issue there. What about regulations? We have standards that are used in building codes that are not fundamentally health and productivity based, and there's really little or no legislative agenda, where we have strong legislative agendas for energy and atmosphere. I met with the Environmental Protection Agency's indoor air group when I was president of ASHRAE, and I asked them what is the current activity on indoor air quality on the Hill, and they said, well, there isn't any right now, but then they went on and added, and there never has been any. Of course, Richard Corsi from UT Austin, former colleague of Jeff Siegel's, told a great story at one of the conferences I attended, where there had been a study done somewhere in Texas, I can't remember if it's Houston or Dallas, to measure outdoor air quality one summer. And I think it was several millions of dollars, $4 million, $5 million. The number's not that important, but he asked for a couple $100,000 to do correlated indoor measurements just to see whether there was a relationship. And to paraphrase the answer that he was given, once air enters a building, from the point of view of the government, it ceases to exist. And I think that's a very telling remark that I've never forgotten for obvious reasons. What about practice and operation? I think that we have raised a generation, many generations of building design professionals, architects and engineers and others, who really do not know enough about indoor environmental quality. Anyone here who's a mechanical engineer who happened to actually take an HVAC course during their education, think about what you were taught. You were taught about all of the thermal and material aspects of the building, and if you were taught anything about indoor air quality, it was probably a section in your HVAC text about ASHRAE standard 62.1, and probably nothing about lighting and acoustics and those other things. So I think that it's hard to do a good job of dealing with something about which you know nothing. Sustainability has not really helped us move forward too far, because I think that most, when they hear sustainability, they really translate that into energy in their minds, and all of the complaints about LEED-rated buildings not working all seem to be about whether they saved energy or not whether they were really better for the people. You don't hear so much about the effect on the occupants. And a third issue is, I think, one of inadequate tools. We've put lots of effort into developing energy modeling tools, load calculation tools, the things you need to deal with the energy problems. We've got emission estimating tools for use of fossil fuels, but really no good practical, comparable usability tools for doing indoor environmental quality, and certainly not coupled together with energy where they need to be. So what do? We have to deal with this imbalanced design emphasis that reduces air quality, for example, to code ventilation rate. Once someone's done with that in the design of the building, they move on to putting their effort into energy and environmental related issues, and we're going to continue to get the kinds of results we have as long as we do that. We need better tools, we need better knowledge, we need to have the research that we're doing get into the field. What would that look like? Here's my idea of a flow chart that would integrate everything together. Instead of going from a scenario that describes the building as a thermal system to an energy model, to an energy cost model, and then adding in the cost of the building and calling that your optimized life cycle cost, we need to couple the energy use of the building with an indoor environmental quality model that actually quantifies in some way the benefits of the level of indoor environmental quality that's achieved, the lighting, the air quality. Right now we're not doing that. You either comply with the ventilation standard or you don't. Can't tell you if I make the air 10% better in some sense, what is the return on that going to be? So it can't really be put into the economic model at this point. We have the tools to do that if we connect them and if we give them the interfaces that they need to have. If we do that, then we can have this kind of integrated analysis. Right now, virtually no one is doing this in a practical sense, but researchers are, and they have been for some time. So let's look at a couple of quick examples here. There's an interesting study on airside economizers that was presented at an ASHRAE conference back in 2005. And the interesting thing about it was they looked at the airside economizer from the point of view of its potential to improve productivity in the building by reducing sick leave. That's a very sketchy sort of concept to use in terms of quantifying, but yet we can still use models that we have to estimate if there's more ventilation, what would the reduction in infection rate be, and what is that worth if we translate that into sick leave. So they used the Wells-Riley equation that some of you may know about to estimate the effect of the increased ventilation that happens when you bring in more outside air to reduce the energy use of the building systems when they're cooling. And they quantified that and compared everything, and here's the results table, and I want to point very quickly to the top set of data there for a building that was designed for 10 liters per second per person, 0.74 air changes per hour of ventilation. In one case, that remained constant during the year. In the other, the economizer was allowed to operate, and on average, it raised the air change rate by about a factor of 2 to 1.46. You see in the vent rate column there, second from the left. So the bottom line in terms of energy savings was that this building realized $1,900 in energy savings over a year, but when the effect on expected sick leave was quantified, it was 13,000 to 16,000, and overall it was a 3 to 8 times greater benefit for the increased ventilation's impact on the occupants of the building than for the energy was saved. And of course, we're already doing economizers because they're mandated by the code in many places, but here's another reason, and it actually looks like it could be a more important reason that no one is thinking about when they do this. One of my students, Bruno Lee, who came from Canada to the US and went to the Netherlands and now is back at Concordia, just started working there as a professor, looked at different ways of reducing infection risk in the building, high efficiency filters or ultraviolet germicidal irradiation. And the question here was for equal benefits, could you use these tools to come up with an economic conclusion about which would be preferable? So we looked at a simple all-air air conditioning system and put various UV and filter options into it, and concluded from all of that fairly high efficiency MERV 12 filters that would be the same in their impact on the concentrations in the space of viable microorganisms was about 10 to 1. And the cost was very low for doing this control. If you look at the bottom, annualized life cycle cost, anywhere from 1 cent per square foot to to 10 cents per square foot. So here, if we leave out the question of productivity, it shows you can do it pretty cheaply and that one option might be better than the other. And the bottom line, though, is that when we did estimate what would the productivity impact be, that came out to be about $3.50 per square foot, which puts us into that 2 orders of magnitude range that I mentioned earlier. So if you use what has been published to come up with these sorts of estimates, those are the kinds of numbers you're going to get. Final one, Johansson's a Swedish researcher who did a dissertation on integrated life cycle cost, including energy, including the cost of the building itself, including health and productivity impacts, and produced some interesting results like the one shown here that shows that if you choose the right type of systems, if you choose a demand-controlled ventilation system that modulates the outside air to match the population of the building instead of providing full outside air all the time with a constant volume system, that you can afford to provide a better level of indoor environmental quality. So these are the sorts of things you could do with these tools if they were generally available to the design community. So let's summarize here. From my point of view, are we putting enough energy into making buildings healthy, to giving them good indoor environmental quality? I don't think so if we measure that in terms of the outcomes. We need research, we need education, we need design and operation standards that are health and productivity based. We need to realize the promise of what happened in the 1980s and started on this path to get a really integrated approach to buildings. What has ASHRAE done? Very briefly here, since I'm running out of time. We've given away 18,000 copies as of end of June of our Indoor Air Quality Guide, which is a very practical document produced by a very good group of authors. We've revised our Green Guide with a new chapter on indoor environmental quality that was produced by the Environmental Health Committee. We had a conference on energy and environmental quality in hot climates in Qatar. We had our IAQ 2013 conference that I've already mentioned that focused on high performance buildings, energy and air quality. And there were some interesting conclusions from that. Pavel Bogucz, who's a well-known Danish researcher, made a couple of points that I identify with very closely. We have a lot of good research, let's use it, and let's not simply keep generating more questions. Let's act on what we're fairly confident of, even though we have incomplete knowledge. And again, the points to take away: buildings are for people, not for saving energy. People use energy, not buildings, and we should promote health and comfort and productivity first and try to do that with the least use of resources and the least impact on the environment. And the next step of this will be our 2016, our 30th anniversary of the IAQ conference, and the theme is going to be defining indoor air quality policy standards and best practices. So that's coming up in 2 years, and hopefully we'll see some of you there. So my final conclusions here: what do we need? Performance-based IEQ. We don't really have it now. Are we doing enough? No, we aren't. Can we do better with existing knowledge? I think we can. I've shown some of that. How do we do it? The right research, education of practitioners, not just researchers, by getting more activity in the regulatory arena and improving standards. Are we going to do it? Well, I'm hopeful. I see some movement, but when, I'm not sure when we'll get there, but certainly we're in a position to start doing that today. And so with that, I will conclude.
We have time for a couple of questions. Before I take questions, I just want to recognize New York State Assemblyman Sam Roberts is in the house. This is Sam's district. His office is right around the corner. So when we're talking about policy, we want to do, actually, we do like productivity of the assembly as a function of ventilation. So thank you, Assemblyman Roberts, for joining us. So, questions?
Well, thanks, Bill. Okay. I agree with you about this.
We have a mic I see is going to come in.
I agree with you about the idea of the integrated approach with the loop related to the cost. But there is a shortcoming. I raised this with Bill Fisk, with Jack Spengler, is when you have things that have a large uncertainty band, the economists know how to handle this, they discount it. Okay? It's built into something called the capital assets pricing model, where the higher the volatility, the higher the discount. So long as we use a deterministic value of indoor air quality, we're not going to go very far. We need to take into account that indoor air quality and its benefits tend to have a very high uncertainty band, especially when you get into a small group or an individual, and we need to actually fold this into the economic assessment. So economists know how to handle this. If we actually engage them in this, they may be able to tell us how to discount appropriately the benefits of indoor air quality to account for the fact that they are highly volatile, okay? Compared with energy that you can measure much more easily and you can know it with a much lower level of uncertainty.
The interesting thing is that you can measure energy, but look at how well we do it at predicting it. When someone designs a building with a whole building energy model, how much uncertainty analysis goes into that, and then you look at what the outcome is, and that's fairly uncertain as well. So you have a perfectly valid point from the point of view of what we need to do to try to bound the problem so we know what we should do with confidence. On the other hand, arguments like that have been used in many spheres to avoid doing something about something that someone doesn't want to do something about, like smoking, right? We had for many years very effective arguments that, well, we're not really sure, and everyone had a grandfather who had smoked 2 packs a day and lived to be 95 years old, and so is it really that bad? And we need to deal with that side of the issue as well. But we are never going to have probably an IEQ meter that reads out with the kind of accuracy of an energy meter in a building.
Can I account for the increase of
I don't remember the number that came up, but you had the chart with the staggeringly different deaths from air quality, which
Yes.
showed the Southeast Asian region, I believe, what SEER stood for.
Mhm.
Is there work being done in places like that by counterparts to ASHRAE or others where there's probably more quantifiable data at hand just by virtue of the numbers and the consequences?
Well, they're certainly measuring the airborne PM levels, and there's been a lot of work done, I think, to try to mitigate it. The consequences are being quantified. I was at the Indoor Air Conference in Hong Kong not that long ago. That was the beginning of July, and there was quite a bit of program there that had to do with those sorts of issues, particularly the indoor one. So I consider that to be an area that's getting a lot of attention. The question for me is it really going to be controlled? What is the commitment to doing something about it, particularly the outdoor aspect of it? If you're China and you need to produce a lot of power to develop, what are your options at this point? Do you pull things back and say we're not going to do it until we can do it cleanly? That they're just starting, I think, to have those discussions now.
When you do interior air quality assessments, do you ever kind of control for material selections? So you have the ventilation rates for a certain amount of outside air pollutants, but how much does source control play into that? Can you reduce your ventilation rates if you make a stronger effort to reduce your source of pollutants within the environment?
Yeah, it should be. I mean, the materials is more maybe Jensen's thing or Jeff Siegel's, but sure, source control is the first step in getting better air quality. But that's only one aspect of it. You do that until you've gotten to where you want it to be. But the fundamental question remains: what criterion are you applying? Yes, you should be able to ventilate less, but are you still using a perceived air quality criterion to decide what that lower level is? And so that's my main concern.
I just want to make a comment. I think we are looking at a population of cohorts whom we are using in our studies that is actually not getting us anywhere in the last 30 years. And I will go back to the example of tobacco smoking. The cigarette smoking issue was actually got some traction because we started looking at children. So if we stop looking at adults, we start looking at schools and children, we probably will have something that is much more lasting in terms of what we can actually put together in terms of what potentially will be the benefits, because the benefits we are projecting are purely financial. As soon as we put the children in the picture, we are not looking at the same financial benefits to start with. So there is no argument that comes out and says, financially this model doesn't work. And I think we need to start thinking, because ASHRAE 35 years ago, many of the mechanical engineers in ASHRAE really knew about 1 or 2 chemicals, carbon monoxide and carbon dioxide, and probably a few others. And then as they started learning a lot more about the other chemicals that we can't see that float in the air, a lot more progress was made. And the same way, we are probably going to have much better impact if we start looking at a different cohort, because we tried to solve the same problem the same way several times for the last 30 years, and we are still at the same point.
Well, I agree with that. That's all I have to say.
Please.
Yeah.
I think you might be in the only field that is envious with the progress the energy and carbon folks have made, because from the energy standpoint, I think most of us feel like we're standing still. Standards are getting updated, but other than that, not a ton has happened. One thing I noticed, though, you were talking a lot about the deaths and such. I wonder how many of those deaths, a lot of them were in less developed areas, are from cooking fires and other in-home particulate, using solid fuel for combustion to do cooking, rather than, say, an office. And so I think there's some confusion there of whether or not that is completely applicable to like a U.S. office environment.
Yeah, no, I actually did say that the indoor was primarily due to biomass combustion for cooking and heating, but the part of it that's outdoor, that's air that everyone is breathing in Beijing or Shanghai or any other major city that you might be in. So yeah, we do need to separate that. But remember that there are places like that around the world. It's not an insignificant issue. I was watching a program about the Dust Bowl, and someone was talking about picking up cow chips to cook on. If you go to, you find pockets of that kind of society, even in what we would call developed countries.
In some ways, though, ends up being a feedback loop of, as they use more energy, without having pollution control on the energy production, the outdoor environment gets worse, and then they need more ventilation, and still not,
Yeah, I actually read in someone's article that the initial motivation for improving the kinds of cooking and heating devices that were being used in homes was because of the energy use. Well, using a lot more fuel than was really necessary. They're not only producing a lot of air pollutants, they're inefficient. So, as always, to go back to your original point, I think that the indoor environmental quality, for a number of reasons, has trailed along behind energy, and even if the results haven't been achieved that we would hope to have entirely in energy and atmosphere, yet they're a lot more impressive than what's been accomplished in these other areas for the reasons that I stated.
More questions, please?
I'd like to pick up on the question of the last speaker, which is a kind of implicit, I wouldn't say conflict, but independence of the improvement in energy systems, the improvement in indoor air quality. Whereas it seems to me that actually your point that there may be more value in improving air quality as far as dollars go than there is in improving energy efficiency could be used to essentially make an alliance between those two goals. You showed one example where energy was improved modestly and air quality was improved dramatically. since there is more value in dollars to the air quality argument, one could almost turn it around and say, by making retrofits to buildings to improve air quality and simultaneously energy efficiency, you'll probably end up with a cheaper bill than if you just attacked energy quality alone.
And I think that's right, and I was showing some examples of that. Of course, you have to remember that there are constraints. We don't want to have an unconstrained optimization of energy without IEQ or vice versa. So we have to decide where we need to go with both and try to get there in a coordinated way. Actually, another example of that that's developing is in the refrigerant world, right? The climate change ozone nexus they're now talking about, because the people who are trying to solve ozone issues came up with good solutions for ozone that were perceived to be problems by those who were concerned about climate change. So it's another example of having to bring them together because they're both important.
Thanks, Bill.